Good morning, mathematicians. This is week 35, our Tuesday column, and we are starting off with dehydration. The desert explorer needs to drink 4 liters of water each day. Her cactus mug can hold 2/10 of a liter. How many cups does she need to drink to reach her goal of 4 liters? That is what we're looking at in this question. Well, what is our whole thing that is being divided? Our whole thing that's going to be broken up is the 4 liters of water that she needs to drink every day. And we're going to divide that up into portions of 2/10 of a liter because that is what her mug holds. Well, the first thing that I ask myself is, what is the relationship about one whole being divided into 2/10 portions? How many 2/10 portions are there in one whole? Well, I know that there are 5 2/10 portions in one whole because there are 10 tenths in one whole. And if I group those into 2/10 portions, that makes 5. But here, I'm actually not just looking at one whole, I'm looking at 4. So that's like multiplying 4 times 5. Well, 4 times 5 equals 20. So that tells me my answer. My answer here is going to be that she needs to drink 20 of her mugs, right? 20 of her mugs is going to give her her goal of 4 liters. Okay, now we're going to move on to a create your own division problem. This says that we need to create a division problem with a 2-digit divisor. There's a qualifier. Another qualifier is that it has to have a quotient of 8 and a remainder of 4. So I need to be able to say that this 2-digit, right? 2-digit divisor, uh, actually, that is dividend, okay? So that's my dividend. It could be 2, it could be 3. And that divided by 2-digit divisor needs to equal 8, quotient of 8, and remainder of 4. Okay. Well, one thing that I see right away is that certainly I could make my divisor 10. I know that fact pretty good because 10 times 8 would give me 80. So far I am looking at needing an 80 here, but then I have to have a remainder of 4. So that's actually going to be adding 4 more, which is 84. So if I write 84 in here, 84 divided by 10 gives me an 8, and then I have 4 remaining. So that's exactly what I'm looking for in all of those qualifiers. So I'm going to make my answer 84 divided by 10 equals 8 with a remainder of 4. But that's not the only answer that you can have. The sky's the limit. You can create your own. Okay? Now let's go to this. Algae Man's seaweed pool measures 8 and 14 5, 6 and 15 hundredths meters. What is the area of his seaweed pool? Well, really what I'm needing to do here is multiply this times this because I know that the length times the width is going to give me the area, and I'm needing to report the area, okay? Now, one strategy that we have found to be true is that we can multiply 84, right? Move that decimal 1 time. So we're really thinking about like 84 times 615. We could find the product of that. Then we could multiply it by a certain decimal. Now, for the 84, we have to have one decimal position, a tenth. And for the 6 and 15 hundredths, we have to have 2 decimal positions. So that means that we're really going to multiply it by 1,000th after we get our product, right? We know that to be true, and that is going to give us the area. I had to do a big equal sign to go through that stylish surround. So now let's go ahead and do that. I'm going to do it with standard multiplication. By the time we end fifth grade, we want to be really masterful at this. Certainly, it's okay if you are still thinking about other strategies as well. But let's go ahead and let's check it with this. I'm going to let my 4 be that first center point. 4 times 5 is 20. Here's my 0, carry my 2. 4 times 1 is 4, plus 2 is 6. 4 times 6 is 24. My first partial product is 2,460. And that is what 615 times 4 equals. Now, I'm going to cross off my 4. I'm going to cross off my carry 2. And I am moving on to the 8, which really is in the tens place, which is why I need a 0. 8 times 5 is 40. Here is my 0, and I'm going to carry a 4. 8 times 1 is 8, plus 4 is 12. Here's my 2, carry a 1. 8 times 6 is 48, plus 1 is 49. So I have 49,200 as my answer to 615 times 8. Now I'm going to add these partial products together, starting with my smallest place value. 0 plus 0 is 0, 6 plus 0 is 6, 4 plus 2 is 6, 2 plus 9 is 11. Here is my 1, carry my 1, and 1 plus 4 is 5. So I have this as my answer so far, 51,660. That's what, let me make a little line here, that's what this equals. But now I have to take this and, actually, I have to take 51,660 and I have to multiply it by 1,000th, which is like moving that decimal point 3 times to the left, right? So my decimal starts here in a whole number. Let's move it 3 times to the left. 1, 2, 3. My decimal is actually going to be between the 1 and the 6. That's my answer to number 1. That's my answer to the area of the pool. So I'm going to write a 5, a 1, a decimal, a 6. These two zeros become optional, of course. Zeros on the end of the decimal are optional. And I need, oh, and actually, now that I look here, I actually had a 6 here. I just didn't rewrite it with that second 6. So that 6 is required. This 0 on the end is optional. But what I want you to remember is that this is area. An area is given in the unit, so in this case, meters squared. Okay, so my answer is 51 and 66 hundredths meters squared. Now, we're going to need a little bit more space because take a look. This has a number 2. This is a doozy. Okay. We have the area of his plankton playground is 3 times as much as the pool. So only the playground is 3 times as much. But notice the question. What is their combined area? So really, boys and girls, we are going to look at this number. The area that we found was 51 and 66 hundredths. But we need to multiply that by 3 for the playground and another 1 because, of course, that was the pool itself. So to make this efficient, I can go ahead and multiply it by 3 now because one of those is going to be for the pool. 3 of them are going to be for the playground because the playground was 3 times as much, right? Some of the students, as I look at your work, multiply this by 3 and then add the 51 and 66 hundredths, and that's fine too. We're going to arrive at the same answer. Now, I'm going to use the strategy of multiplying 5,166 times 4 and then accounting for that decimal. So then I'm going to go back and multiply by 100, right? So let's go ahead and ignore the decimal for now, and let's do our multiplying. 6 times 4 is 24. Here's my 4, carry my 2. 6 times 4 is still 24, but add 2 and we have 26. Here's my 6, carry my 2. 4 times 1 is 4, plus 2 is 6, and 4 times 5 is 20. Now we have to remember that we're needing to move that decimal point 2 times to the left because, because here we are going to be multiplying. So we're going to go to the left. We're multiplying by a decimal. So we're going to go 1, 2. I'm going to move my decimal right in there. So what is the combined area? Their combined area is 206 and 64. And this is going to be meters squared because, again, we are reporting an area. All right, we're still going. We still have a question 4 and a question 5 for today. Let's go ahead to Charles Darwining. Charles Darwin says the following, that 941 divided by 26 equals 36, remainder 5. Is he correct? And explain. Well, as you did your work, I am sure you found the basic answer to be yes. He's correct. That is true. Now let's go ahead and talk about one way that you could explain this. If I, kind of like I did here, I thought about, well, my 10 times my 8 is 80. See how then I added my remainder. I'm going to do the same thing here, right? So first of all, I am looking at, like my 36, certainly my 36 here, um, and my 26, how can I multiply those things together? Well, let's start with just doing 36 times 6, right? The 36 times the 6. When you multiply your 36, or rather, I'm sorry, when you multiply your, let's do it this way. When we multiply our 26 times our 6, actually, this is what I saw most of us do. The 26 times just the 6 of our answer. When we did that, 26 of our divisor times the 6 of our quotient, many of us found that to be 156, and that's true. Then what we had to do was we had to think about, okay, but we still had our 26 times our 30 to multiply by. See this 3 here? So between the 6 and the 30, we're multiplying by the whole group of 36. And we found that 26 times 30, when you did this, you found that to be 780. Okay? So between both of those, we have multiplied 26 times 36. But what we have to do is add those together. So now I'm going to take my 156 and I'm going to add my 780 or 780. No, and when I add those two things together, I find an answer of 936, which no, it doesn't match yet because I have to add the remainder. Now, if I have 936 and I add 5, take a look. Now I am to my dividend of 941. So my explanation is really here in these equations that I have built to show multiplying my 26 by 30 and then my 26 by 6, adding those two together and then adding the remainder. So Charles Starr winning still is winning. He is correct. All right. Now we have some fractions to take a look at for today. Our very first fraction that we are working with is 5 and 4/5. Actually, this is minus 2 and 2/3. So let's think about this. Do I have denominators that are the same? No. Can I skip count by 5 to get to 3 or skip count by 3 to get to 5? I can't. So this one, I'm going to have to change both of them, aren't I? I'm going to have to change this denominator and I'm going to have to change this denominator. Now, if I skip count by 5, 5, 10, 15, right away I know 15 is also a multiple of 3. So I'm going to create a denominator of 15 because that's going to give me a smaller denominator than if I just multiplied those together. Not. It's going to give me the same thing. So here we are multiplying our 5 times this denominator, which whatever we multiply our numerator by, we're going to multiply our denominator by. So we know that 4 times 3 is 12, and 5 times 3 is 15. Now, again, I talked you through the strategy because sometimes you can create a smaller denominator, but in this case, it really didn't matter. We are multiplying our two denominators together. Now, 5 and 4/5 equals 5 and 12/15. Okay? Now here we're going to multiply our 3 times our opposite denominator 5. So we're going to multiply our numerator by the same thing. 3 times 5 is 10, and of course we already have our denominator. Well, 2 and 2/3 means the same thing as 2 and 10/15. So those are the same. Now we can subtract because we have a common denominator. Well, if I have 12/15 and I lose 10/15, I have a difference of 2/15. And 5 minus 2 is 3. So my answer to this question is 3 and 2/15. Let's go ahead and write down below, we have 3 and 2/15. Now we're still not done. This one definitely takes some thinking today. Now we're ready to work on number 2, which number 2 is 1 and 3/4 plus 1 and 2/3. Now, with this one, I can't skip count by the 4 and get to the 3, 4, 8, 12, skip count by the 3 and get to the 4, 3, 9, 12. But I do see the very first multiple that matches is 3, which is also what you get when you multiply 4 times 3, right? So that's exactly what we're going to do. Kind of some similar thinking to our last question, but this one's addition. So I'm going to be creating a new fraction, an equivalent fraction, with a denominator of 12. Well, 4 times what gives me 12? 4 times 3. Whatever I multiply the denominator by, I multiply the numerator by as well. I have 9/12. So 1 and 3/12 is equal to 1 and 9/12. Now we're going to do the same thing down here. 5 times what? Actually, this is not 5, this is 3. I knew it right away because that wasn't adding up. Now we have it. 3 times what gives us 12? Well, that's going to be 3 times 4. Whatever I do to the bottom, I do to the top. 3 times 4 is 12. 2 times 4 is 8. So 1 and 2/3 equals 1 and 8/12. We have this ready to add. Now I have 9/12 plus 8/12 is going to give me 17/12, an improper fraction, but that's okay. 1 plus 1 is 2. Now, this is technically right, but it's not in the best form. We want to have a mixed number be a whole number part and a proper fraction. So I'm going to ask myself, I know I have my 2, but with this 17/12, how many times does 12 go into 17? It goes in one time. And what's left over? What's left over is 5/12. So now when I join this together, I have 3 and 5/12 as the best form for my answer, 3 and 5/12. Let's go ahead and let's write that down below. We have 3 and 5/12. One more, stay with me. We are looking at 2 and 1/4 plus 1 and 5/6. So I've written that down here. This is our question 3. Now, I cannot double the 4 and get to 6, right? So again, I'm thinking about multiples. 6, 12. Already I'm at a multiple of 4 because certainly I can do 4, 8, 12. Both of them have a good multiple, a good low multiple in common. So this is an example of where I am not just going to multiply my denominators together. If I multiply my denominators together, 4 times 6 gives me 24. So I can actually get to a lower common multiple if we see it. Now, if you don't see it and you multiply the denominators together, you're still going to get an equivalent answer. It just might be a little bit larger. Okay? Now we have 4 times what gives me 12? Well, that's going to be 4 times 3. Whatever I do to the bottom, I do to the top. 1 times 3 is 3. So 2 and 1/4 equals 2 and 3/12. Now we have 1 and 5/6 equals what over 12? Well, 6 times 2 equals 12. What I do to the bottom, I do to the top. 5 times 2 equals 10. And yes, I'm going to bring that one over. Now I am ready to add, right? 3/12 plus 10/12 gives me 13/12, just a little bit over 1. And 2 plus 1 is 3. Now, I know I have that 3 in the front. How many times will 12 go into 13? It goes in one time, and there is 1/12 left over, which when I join my wholes, I have 4 and 1/12. So, boys and girls, definitely give yourself a pat on the back. Our answer here is 4 and 1/12. Now, truly, we have reviewed so many things here. We have reviewed fractions. So we have some operations with fractions here, don't we? We have got some division of whole numbers, which we use multiplication of whole numbers to help us to explain. Here, we have multiplication, not of whole numbers, but of decimals, right? Here, we definitely were thinking about division of whole numbers to create our own equation. So certainly this was a little bit of a higher level of learning. And in this one, most especially, we were also thinking about division, but we were doing division with whole numbers and decimals. So there have been so many standards that we have reviewed in this Tuesday column today. Definitely, mathematicians, give yourself a pat on the back for persevering through all of that review. It is good for the brain.